All right, so this is the last section that's test-worthy from Chapter 13. It's Section 13.6. And we will, on test purposes, be able to do 100% of everything from this section on your calculator. So you want to have your TI-83 or TI-84 handy. And homework-wise, we just want to do 15 through 25 odds. I printed out the little printout from my website. You don't really need it. In fact, I'll briefly talk about what's on my little handout, and I'll just do problems from the text. And I'll do one or two problems by hand from the text, and then I'll use my calculator to do everything. And I expect you to just be able to do this on your calculator. The computations, some of the computations that are necessary in this section, they're just a little bit tedious. And I'm not going to force you to do the tedious computations because generally people use technology to do this sort of computation. So this section, it's titled Measures of Dispersion. And this is getting closer to, if you get to take a statistics class, what you might start studying. So my handout, it says that, like in the last section, we did mean, median, mode, and mid-range. And sometimes those numbers aren't enough for you to make decisions. And so there's an example here that we have two different companies that make airplane engines. And companies A, their airplane engines, if you get an airplane engine from that company, it'll last 1,000 hours before you need to repair it and it fails. Company B, its airplane engines only last 950 hours on average before they fail. So on the surface, it looks like company A, well, I'd want to get the company A engine because it's going to last me 50 hours longer on average than the company B's engine, so A's is better than B's. That's not necessarily the case. And so this little paragraph here says, well, what if we examine the numbers a little bit more closely? Let's take A's engines and let's just pretend that half of company A's engines fail at 500 hours, the other half fail at 1,500 hours. So none of them actually fail at 1,000, but on average, if one fails at 500, the other fails at 1,500, you get an average of 1,000 hours. If you buy a company A engine and you're lucky, you'll get one that lasts 1,500 hours. If you're unlucky, you get an engine that lasts 500 hours. So there's a certain risk to buying the company A engines. Yes, it's true on average they last 1,000 hours, but half of them do 500, half of them do 1,500 hours, and so I'm risking getting a repair quickly. Whereas if I read what it says for company B, although they're at 950 hours, they usually fail, but this says, well, half of them will last 975 hours, the other half will last 925 hours. That produces an average of 950. So they do last less, but if you look at the spread for A's, I mean, if I get an engine from company A, it's either going to last 500 or 1,500 hours. If I'm unlucky, I'm getting repair really quickly. If I'm not lucky, I get a way long time for a repair. But the engines from company B are more predictable. Their lifespan is a narrower, it's less dispersed, and I might feel safer buying the company B engine knowing that I should at least get 925 hours as opposed to getting 500 hours. So both of these companies have kind of the same average lifespan for their engines before they fail. Actually, B is a little bit less. But if I'm purchasing an engine for if I had an airplane, I might choose company B because it's more predictable. It's good. I know that it's going to last between 925 and 975 hours. And that's really, it's essentially 950 hours. Whereas the A, their lifespans are so variable that I'm rolling the dice when I buy a engine from A a little bit more. But I could get way lucky. So this is just to show you that, averages that are mean averages that are about the same don't necessarily tell the whole picture. How much the data is spread out might give me more of a feeling for the than the average does. And so in section 13.6, we're finding out how far data is spread out. So let me maybe do some of this problems from this handout. So the first thing that we have to worry about finding about data in section 13.6 is how far spread out the data is. That's the range of the data. The range of the data is the high minus the low. For company A, if its high average is 1,500 and its low occurrence is 500, the range for company A's of how far the engine life is 1,000 hours, whereas in company B, the range of how long its engines will last are the difference between the 975 hours and the 925 hours, or 50 hours. In general, the range of any data, I don't need to know the mean, it's just the high minus the low. So in this little bank of data right here, the high number is 30, I think. The low number is 5, I hope. The range of this data is 25. So that's one of the two concepts that's necessary in section 13.6 is the range of a group of data. The range of a group of data is just the high amount minus the low amount. Let me get into the text and do some problems from the text. And in the text, I'm focusing on problems 15 through 25 odds. So in problem 16, I'm given some data, the numbers 10, 10, 14, 16, 8, and 8. I'm asked to find two things. The first thing I'm asked to find is the range. The range is just going to be the high number, which is 16, minus the low number, which is 8. The range of this data is 8. I don't need my calculator to do range. It would be silly to use my calculator to find range. The next number that I'm asked to find is called the standard deviation. And the standard deviation is another number that explains how spread out the data is. So the bigger the range, the bigger the difference between the high and the low number. Standard deviation, the bigger the standard deviation, the farther each number is from the mean. I say the standard deviation is the average squared distance from the mean. Looking at my handout, I won't do the computation here. My handout has two sets of data. So on my handout, I have this set of data, the data that has the numbers 5, 8, 9, 10, 12, and 13, and a set of data that has the numbers 8, 9, 9, 10, 10, and 11. The top set of data has a mean of 9.5. The bottom set of data has a mean of 9.5. So both of these data sets have a mean of 9.5. If I look at the data sets, the top one has a range of 8, the bottom one has a range of 3. The top one is more spread out than the bottom one. There's a number that's associated with each of these data points called the standard deviation. That's another way to describe how spread out the data is. So the range for the top one is 8, for the bottom one is 3. That number is easy to get. The number that's not so easy to get is the standard deviation, and of course it's not on my sheet. Let me compute the standard deviation infinitely quickly because I know how to use my calculator to do this. And I will write down that number for you real quickly. The standard deviation of the top set is 2.88. So that's a number that talks about how the data is spread out that I got via my calculator that eventually I'll show you how to do in your calculator. Now I'll do the bottom set. This says on average each of the numbers is 2.88 units from the mean, but it's not quite that nice. I mean, it's subtler than that. And then I'll do on my calculator again, and then I will show you by hand. In the second piece of data, the standard deviation, and this is probably not the best lecture. I just thought I'd work this out on my handout, but I didn't. It's 1.04. So a standard deviation is a number that tells you how far the data is spread out, and technically I say it's the average squared distance from the mean. We'll see that when I do my computations. But when I look at the number, the standard deviation of this data, it says 2.88. The standard deviation of that data is 1.04. Both of these numbers, if you found the mean of 5, 8, 9, 10, 12, and 13, or if you found the mean of 8, 9, 9, 10, 10, and 11, both of those have an average of 9.5. So how do I say this data is more spread out than the bottom data? The standard deviation is a number that tells you how far the data is spread out. The bigger the standard deviation, the more the data is spread out. The smaller the standard deviation, the more the numbers are like each other. So this top set of data, the numbers 5, 8, 9, 10, 12, and 13, the standard deviation, the number that tells me how far that data is spread out, is 2.88 compared to the 1.04. So that's what we're going to figure out by hand once or twice, and then via my calculator most of the time. So to find this number that tells me how far each piece of data is from its mean, I'm going to do it by hand once or twice, and then by your calculator. And so this is not required for the test. We don't need to be able to figure out the number called standard deviation, which is a measure of how far each data element is from its mean. Usually, to compute standard deviation, I first find the mean. If I'm stuck doing this by hand, and maybe I'll do one by hand, because nobody will want to do this once they see this. So I'm going to find the mean of this data. I'm going to go 10 plus 10 plus 14 plus 16 plus 8 plus 8. And there are 6 numbers, so I'm going to divide by 6. Second quit, can't see that. I'll go 10 plus 10 plus 14 plus 16 plus 8 plus 8. And I'll actually do that right. Plus 8 plus 8, extra plus sign there, delete. I get 66 divided by 6 is 11. So the mean of this data is 11. If I look at it, 16 is 5 away from 11, the 8s are 3 away from 11, the 14's 3 away from 11, but the 10s are only 1 away from 11. I would say maybe on average, each element maybe is about 3 away from the mean. So the standard deviation that measures how far this data is spread out, I can't imagine it's too much more than 3, because on average, most of the numbers are within 3 of the mean. But that's not so nice. To do the standard deviation by hand, I'm going to make a table. And in my table, I'm going to write each of the data pieces. I don't have to write them in ascending order, but I like to, so I will. My data pieces are 8, 8, 10, 10, 14, and 16. To find this number called standard deviation, which measures how far the data is spread out, the next thing I need to do is compute the data piece minus the mean. So for each one of these pieces, I'm going to subtract the mean, which is 11. And that's the number I'm going to write in the next column. So I'm going to go 8 minus 11, which is going to give me negative 3. 8 minus 11 is going to give me negative 3. 10 minus 11 is negative 1. 10 minus 11 is negative 1. 14 minus 11 is 3. 16 minus 11 is 5. Next thing I'm going to do is square that amount. Negative 3 squared means negative 3 times negative 3, which is going to be positive 9. So in the square column, I'm just going to multiply that number by itself. Multiplying any negative number by itself, I get a positive. Second, negative 3 times negative 3 is negative 3 squared, which is 9. Negative 1 times negative 1 is negative 1 squared, which is 1. Negative 1 times negative 1 is 1. 3 times 3 is 9. 5 times 5 is 25. So I wrote the data column after computing the mean, subtracted each of the data pieces minus the mean 11, got that column, squared each number. Now I'm going to sum the far right column. So I'm going to add up these numbers, 9 plus 9 plus 1 plus 1 plus 9 plus 25. And I get 54. And now I'm going to do this computation, which is, so the standard deviation of this data is found by taking the square root of this number divided by 1 less than the number of data points. There were 6 data points. 1 less than the number of data points is 5. So I'm going to do the square root of 54 divided by 5 on my calculator. On my calculator, to do that, I hit my second key, and I hit the x squared key. Then I type in 54 divided by 5, and I close my parentheses. And when I hit enter, the standard deviation for this set of data. So on average, each piece of data is about it says, I'm going to round to 1 decimal. I don't know. Oh, the author wants us to do 2 decimals. My calculator gives me 3.286. This 6 is going to round that 8 up to a 9. So I'd say for this particular data set, on average, each piece of data is about 3.29 from the mean. Some of the data is only 1 from the mean, some of the data is 3 from the mean, but the other one that's 5 from the mean. So the standard deviation is a measure of how spread out the data is, how much each piece of data varies as opposed to the mean. So this isn't a horrible computation, but it's not a computation that you're required to do by hand. So let me show you on your calculator how you can compute standard deviation. And it's slightly tedious, but not as tedious as memorizing this by hand. To do standard deviation, you get your calculator out. Let's clear out the whole screen. Step 1 is to enter the data. So you gotta get your calculator out right now. A lot of times when I start doing stuff in class, students work about 5 minutes behind me, and I'll do a problem and they'll just wait forever to write. I don't understand it, but you should get your calculator out right now and just don't watch me. Follow along with me. So after you have your calculator, clear out the main screen, turn it on, hit the stat button. So make sure you can do this. If you couldn't hit the stat button, stop the video, pause it, and make sure you can find the stat button and hit it. After you hit that stat button, you get to this screen, and you're going to want to The edit is highlighted on this. I just hit enter on it. My calculator will bring up a screen, and my screen has a bunch of junk in it. But what's going to be important is to find on the top where it says L1, I'm going to scroll up to that. You notice I can scroll left. I can scroll right when I get up to the top. You need to find the list that says list 1. L1 means list 1. Notice mine, I entered something in it already. I need to clear out my list. So I hit my stat button. I hit enter. I found list 1. I arrowed up to the top so the L1 was darkened. I'm going to hit the clear button and hit enter. That's going to wipe out and make it so that list has nothing in it. If your list had nothing in it, if you went to the clear button and hit enter, it just wouldn't do anything. So you need to have on your calculator the L1 with nothing under it. To get that again, stat, enter on edit, boom. Now I'm going to enter the data in any order. So the numbers are 8, 8, 10. I'm just hitting the enter after I type the number in, 14, and 16. So I've entered the numbers. I've only entered those 5 numbers. I didn't enter any zeros or anything. I entered the 6 data points, 8, 8, 10, 10, 14, and 16. So I started off, I did stat, enter, went up to the top of my list, clear, and hit enter. Then I entered the data, 8, 8, 10, 10, 14, and 16. Done entering the data, hit the stat button again. So I just entered this list. I'm going to hit the stat button. Brings me to that screen that I've been at already. I hit my right arrow to get the calc highlighted. So instead of having both the edit and the one highlighted, I arrow with my right arrow and I get the calc and the one highlighted. I hit enter twice and my answer is going to be staring at me. I just need to find it. So enter once, enter twice, and magically, there it is. This 3.286, that's exactly what I got on my calculator by hand. So the standard deviation is this SX number, 3.286, and it's going to be 3.29. I'm going to write down for my standard deviation. Let me do problem 18 by hand and via my calculator. Again, on the test, you're only responsible to be able to find standard deviation via your calculator. So in 18, I'm supposed to find the range and the standard deviation, and the data that's given to me are the numbers 3, 7, 8, 12, 0, 9, 11, 12, 6, and 2. The range is the high number minus the low number. The high number is 12. The low number is 0. So the range is 12. To do the standard deviation, I would just break out my calculator because I don't care to do these by hand. But to do the standard deviation without my calculator is not that hard. I can't even spell standard deviation right now. Something like that. Deviation. By hand, which you're not responsible for, I'm going to find the mean. The mean, I'm going to go 3 plus 7 plus 8 plus 12 plus 0 plus 9 plus 11 plus 12 plus 6 plus 2, and I divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to add up those numbers and divide them by 10, so let me add the numbers up first. 3 plus 7 plus 8 plus 12 plus 0 plus 9 plus 11 plus 12 plus 6 plus 2. I get 70. 70 divided by 10 is 7. So the mean is 7. And now I'm going to do the standard deviation by hand. I'm going to write my data in ascending order. So I'm going to write 0 first, 2 second, 3 third, 6 then 7 then 8. Nine, 11, 12, and 12. Out of room here. I'm going to write my last 12 up there. In fact, I'm going to bring out a new sheet of paper to do this again. I'm not happy with that. So let me start my standard deviation nice and over. To do a standard deviation, you don't have to do it by hand on the test, but if you had the desire to do it by hand, you'd start off by taking your data and writing it down. So I see 0, 2, 3, 6, 7, 8, 9, 11, 12, and 12. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items. So data, perfect. Next column is going to be data minus the mean. And so for each one of these, the mean is 7. So I'm going to go 0 minus 7, 2 minus 7, 3 minus 7, 6 minus 7. For each one of these, I'm going to subtract 7. I usually don't show the minus 7, but that's what I'm doing for my middle column. 0 minus 7 is negative 7. 2 minus 7 is negative 5. 3 minus 7 is negative 4. 6 minus 7 is negative 1. 7 minus 7 is 0. 8 minus 7 is 1. 9 minus 7 is 2. 11 minus 7 is 4. 12 minus 7 is 5. 12 minus 7 is 5. Now I'm going to square each one of these. Negative 7 squared is negative 7 times negative 7, which is 49. Negative 5 squared is negative 5 times negative 5, which is 25. Negative 4 times negative 4 is 16. Negative 1 times negative 1 is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 4 times 4 is 16. 5 times 5 is 25. 5 times 5 is 25. That's my far right-hand column. Now I'm going to sum these. So I'm going to go 49 plus 25 plus 16 plus 1 plus 0 plus 1 plus 4 plus 16 plus 25 plus 25. That adds up to 162. The standard deviation is going to be the square root of 162 divided by, there's 10 data pieces, 1 less than 10 is 9. So I'm going to do the square root of 162 divided by 9. So I go second, x squared, 162 divided by 9, close my parentheses. My calculator gives me 4.242, and I'm going to say the standard deviation is 4.24. Absolutely not required at all to do a standard deviation by hand. Nice if you can do it, but doesn't matter to me whether you can or can't. Let's do the same standard deviation, get this 4.24 via my calculator. So this data was more spread out. The mean is 7, but there's more pieces further away from 7. On average, each piece is 4 from the mean. Or, yeah, that's what that says. So standard deviation, hit your stat button. Step 1 is to have the edit and the stat simultaneously highlighted. So the edit is highlighted in black and the 1 is highlighted. I hit enter. That gives me that list 1. I arrow up to the list 1. I hit my clear button and enter. It clears out my list. I'm going to enter the data. It doesn't matter the order that I enter it in, but it's staring at me written in a nice order. I'm going to leave it in that nice order. You got to get every single data piece in. If you don't get every data piece in, then you're going to get the wrong standard deviation. And let me double check to make sure I have 10 pieces of data. Okay. Okay. I'm gonna be like 10 more minutes. So okay. So when I look at my data, there's 0, which is 1. There's 2, 3, 4, 5, 6, 7. 8, 9, 10 pieces of data. So I think I've got all my data in. And I double checked it to make sure. So I've got my data in. I hit my stat button. And then I go over to the calc. And I just hit enter twice. Enter once, enter twice. And this SSX number, that 4.242, is exactly the 4.242 I got by hand. So the standard deviation is 4.24. If you're in a real statistics class, you start doing stuff with the standard deviation. You do z-scores and all sorts of things that are kind of complex with standard deviation. Standard deviation is kind of a fundamental part of statistics that we won't get into so much. We'll just get used to working your calculator as much as anything. So let me do one more problem. Let me do a wordy problem. It says, number 24 says years to retirement. It says 7 employees at a large company were asked the number of years, additional years they plan to work before retirement. Their responses are 10, 23, 28, 4, 1, 6, and 12. Find the range and the standard deviation. So any problem that I ask you from section 13.6 on the test would just ask you to find the range and standard deviation from a bank of numbers. Although problem 24 is a word problem, really it's giving me 7 numbers, it wants me to find the range and the standard deviation. These numbers represent the how long before people are going to retire. So in problem 24, the number of years that people are going to work before they retire are 10, 23, 28, 4, 1, 6, and 12. And the range, I don't need my calculator to find the range. To find the range, I must take the high number, which is 28, minus the low number, which is 1, which is 27. To do the standard deviation, if I'm not working by hand, I don't need to compute the mean. My calculator can do that for me. So I'm going to do the standard deviation, and I'm not even going to enter the numbers in a nice order. I'm going to hit my stat button. I'm going to hit enter on edit. Go up to the top of my list and clear it out. You notice my calculator has more lists going on. It doesn't matter. I don't need to worry about those lists. I'm going to enter the data, which is 10, 23, 28, 4, 1, 6, and 12. I've entered the data. After I enter the data in, I hit my stat button. I arrow over to calc. I hit enter twice on one variable stats. And the SX is the standard deviation. My calculator tells me that's 10.016. I'm going to round the 1 to a 2. The instructions in this somewhere, it says round to 2 decimal places. I'm assuming that's the case here, although I don't necessarily see that. But I'm going to say it's about 10.02 years is the standard deviation on how many years the people are looking to retire. So every single homework problem that I picked, the problems between 15 and 22, just give me a list of numbers, ask me to find the range and the standard deviation. The range you don't need any special skills for, it's just the high number minus the low number. The standard deviation, you don't really need to make the table and find the mean. You could just enter the values on your calculator and take the value from your calculator. And the 2 word problems, 23 and 25, they're not really any different than this problem 24. They're technically a word problem because they're words, but buried in the word problem for 23 and buried in the word problem for 25 is just a list of numbers. And within that list of numbers, we're asked to find the range and the standard deviation. And you notice when I did problem 24, I didn't do anything but punch the buttons on my calculator to give me the standard deviation. And that tells me on average, each element is about 10 years from the mean, basically. So hopefully that's enough to get you through section 3.6. Again, you're only responsible for problems 15 through 25, the odds and the homework. And on the test, all I would expect you to do from this section is to find the range and the standard deviation from a set of numbers, and that's all you're going to need to do. All right, that should be hopefully good.